All right, everybody, welcome back to another OpenShift Commons briefing. Today we have Ricardo Zanini, who's from Red Hat and a senior software engineer. And we're going to have a topic that I don't really know a lot about because I haven't heard a lot about it, which is why we've invited him here to talk about event-driven applications using Kogito serverless workflows and Knative. And so Knative we've had a lot of talks about, but Kogito is, I think I'm pronouncing it mashing up the name wrong, but we'll let Ricardo tell us a lot more about this, and then we'll have live Q&A after the presentation and the demo that he's going to give. So take it away, Ricardo, and introduce yourself, tell us what you do at Red Hat, and tell us all about this.
Sure. Yeah. Thanks for having me, guys. Well, my name is Ricardo, like Diana said. Today we're going to talk about event-driven applications and how we can create those business applications using the serverless workflow specification and on Knative platform. Well, I'm a software engineer. I work with the Kogito actually project, and I'm also helping the CNCF Serverless Workflow Project specification as well. So we work in the both ends in the doing the specification side, specifying the workflow DSL, and also in the implementation in the Kogito engine. Well, let's get started. Let me see if I can. All right. In the agenda today, I'm going to introduce you guys the serverless workflow specification and what we are doing there. Just a brief introduction to the project. I will try to not talk too much about it because there's a lot of subtleties that you should take a look in the specification and figure yourself for all other details. And about the implementation itself that we are working on right now, that is the Kogito project that we call. It is a business application project for designing and creating business applications. And after that, I will introduce a small use case. If for someone to feel comfortable, it is like an online store order processing. So it is super simple use case. Everyone is super familiar, I hope so. And we are going to run a super short demo as well, exemplifying how the workflow is reacting upon events and what he is doing on a Knative overall platform. So about the CNCF serverless workflow specification, we say CNCF because the serverless workflow project, it is a sandbox project on CNCF institution. So you can go there in the sandbox project and you see the serverless workflow specification project in there, and we are accepting contributions, and then it is open source, Apache 2 license. So you can go there and then figure things out, ask questions, and maybe introduce some new features that you like, or if you're keen to implement the specification as well, we can help. We have SDKs, we have a lot of tools around the specification that can help you to understand, to implement, maybe use the specification in your company as well. So what it is, the serverless workflow specification, it is something that we are targeting. It is to create a declarative workflow language. So based and to be target for a specifically serverless computing technology domain. So that means reading events, producing events, consuming events, correlating them, call functions outside the scope, have all those things run smoothly. We can out-escalate the functions, up and down, and do all those features that you already know about serverless computing. But within having this in mind in the workflow language as well. This quote I brought from the website, so you can go there and visit the website, understand what it is with more details about that. Why we start with this crazy project, why it is important for us? Well, first, that we believe that workflows can capture and organize business requirements. So what it is, you can instead of grab your maybe Java, Go, or Python code and bring to your business analyst and explain to them, hey, here's what we are doing in this service, here's what is going on there. Look at these conditionals here, we're doing this and that. Instead of that, you can just bring the workflow to your business analyst, to your business person, and explain to them what is happening there, and they can understand. They can even help you, design the workflow, or they can even create a workflow themselves and handle it to you in order to have that run into a runtime maybe. So that's one of the idea behind it. The specification also targets the be a vendor neutral, platform independent workflow language. So what this means that we do not tie the specification with a specific vendor. It is not Kogito, it's not anything like that. It is just the specification. Anyone out there can take the specification, implement in your runtime, and have a workflow runtime running, based on the specification. It is platform dependent because we're not tied with a specific technology. We do not say, hey, the workflow must be implemented in Java, for instance. This is not the case. So anyone can just bring the specification and share and use that as they please in their implementations. So imagine that having this common way of describing our workflow, we can potentialize and creating some common libraries to be shared among all the runtimes, the implementations itself. We can create tooling around it, infrastructure around it, around all the workflow, and having all of them to have a common way to describe something and create something together. That's the nice of being an open source specification. So like I said, being vendor neutral, we increase portability, productivity, and learning curve. You don't have to learn all of those workflow language that is out there, because nowadays, if you go in the IT news, you see that every day, every week, we have a new workflow engine out there. So instead of that, we are proposing this, like a specification that can be run in lots of runtimes, and those runtimes can be offered by to be run on Kubernetes, on OpenShift. Google Cloud can have a runtime for the specification as well. AWS, Azure, whatever cloud provider out there, they can offer their own workflow service based on the specification. That's a win-win situation that we believe, that everyone implements the same DSL for specifying workflow. So the users would gain a lot on that. The specification is based on standards. So we looked around and saw lots of standards out there. So for instance, to define an event, like I want to consume this event in order to start my workflow, or I want to produce an event at the end of my workflow, or I want to produce an event if I go through this branch on my workflow. And we use the Cloud Events specification to define these events in the workflow definition file in the workflow definition itself. You can also run and not run, but call external RESTful services, for instance, using the workflow specification. And we use the Open API to declare how you can create those calls from the workflow itself. So when you for instance, you want to call, when you receive an order, you want to call an external service to validate your order to do something else, and it is a RESTful endpoint. You can express that call using the Open API specification. So you bring the Open API interface into the workflow, and you specify which function in there that is defined in the Open API specification that you wish to call using the workflow DSL. Also, it is of course based on workflow patterns. So there is execution handle, order, error handling, data management, data transformation. So there's lots of patterns that we envisionize in that we view as useful to have in the DSL in the specification itself. You can see lots all those information in this link here that it goes to the specification, and you see all the features that we have in there. Well, the workflow itself, it is based on a state machine. diagram. It is. I say it is based because we have start and end conditions in our workflow. So when you start and you go from state to state, in a fluent manner. So each state is responsible to do something. It is responsible, for instance, to produce an event, or to call an external function, or to decide to split between two branches, or to go to one branch or to go to another branch, can call not another subflow, for instance. And there's a lot of type of states that we have in the specification. And as I said, you can go to the specification and see in the details every one that we support that we have in there. And if you feel like that we don't have something that it might be interesting, you can propose a PR, or send or reach out to us and say, hey, this should be nice to have in the specification, and we can talk together and figure that out. For the data processing itself, it is like you enter with data and you go out with data. So in between, you have this pipeline of states, going through one after each other, and then you can have like a data processing with the data that you're expecting to receive on your workflow. The specification has like those three main, this is the backbone of a workflow, let's say it this way. We have functions, events, and of course the control logic of the workflow. The first thing is the functions. We define the functions as, for instance, a call to a RESTful service, or a call to a gRPC API as well. So you can define the functions, the spec file of the Open API, for instance, the ID of the function that you'd like to call in this section of the workflow. In the event section, you declare how you're going to consume and how you're going to produce those events within your workflow. So, for instance, you are listening to our ordered event and you're producing maybe shipping events, or you're producing order approved events, or in a scenario like a bid service, you are listening to bid events, and you're producing maybe notifications for users that are listening to that bid, for instance. So you can go crazy and do whatever declaration of events and as you please, as your business needs in this section of the workflow. And the states, it is not the least, but not the least important part of the workflow control logic. That is where you describe the workflow and what this workflow is doing, like the data processing and how things are going to go. They're like calling these functions, or producing these events that you declare in there, or consuming events that you declare, or branching the workflow, the run of the workflow into more subflows of whatever control logic that you come up with, or your business need in this this section of the workflow. As always, all slides that I linked here to a specific session in the specification, so you can go there and see for yourself all of the details of each session and understand more in details of what we are trying to express in here. I'll try to be brief, because the presentation can be long if I stay on one or other details. Well, every time that we present the specification, talk about specification events, people ask about implementation. So, well, it is nice to have a specification, and it is also nice to have an implementation, right? Because that's the point of having a specification. You don't just create a specification to be in there. You create a specification to be implemented. So we took the specification. Now talking about the Kogito project, we took the specification and say, hey, there's a petition here, and we can actually implement this a specification and offer to our users a way of them to declare their workflow using JSON or YAML files in a declarative way. And also, if there are other vendors out there implementing the specification, they can migrate to Kogito easily, using the same thing that they learn with this DSL in other implementations with Kogito as well. So it's a work in progress. So we are in tech preview actually right now. Community wise, of course. There is some limitations of the implementation that we also we are working towards to implement, but the basic things are there, and I'm going to show you guys. About a little bit about the Kogito itself. It is I like to call this like a cloud native solution. It is a project with lots of components, so I'm calling like a cloud native solution for you to build business applications. So business applications that you can solve business problems. And then what I mean by that, it is like we have an engine that is capable to process rules in a specific domain-driven DSL. So imagine that you're insurance company, and you want to define how you're going to process that super details, lots of computations and calculations that it is more or less cumbersome to have that in your code base. So you're externalizing rules, and you have all of them defined on those rules, and you can give to the engine in order to run it. We have also an engine capable to run complex decisions based on the DMN standard. We have, of course, the serverless orchestration feature that is super brand new, something that we are working now. That is the implementation of the CNCF Serverless Workflow Specification. We also have an engine capable to run BPMN based files. And we offer some tools focused on cloud, for you can bring everything, all your business applications that you created with Kogito to the cloud. So we have a specific tooling for that. We have like editors. Since it is a business application driven project, it is of course we have editors for you to design and create your BPMN process, for you to create and design your DMN decisions as well, your rules, and that you can download on a VS Code marketplace. We have an online editor as well. If you go bpmn.new or dmn.new, you see our online editor there, and you can start scratching your process or your DMN right away. You can also download it from our website, the Standalone Editors. We are an engine, like I said, based on Drew's GBPM and Object Planner. It's you, of course, if you're a long-term Java developer, of course, you should heard about those during your career, like Drew's GBPM. They're super famous. Yeah, popular, let's say. That's correct, the correct word. There's super popular frameworks out there to run rules and process based on BPMN. We are also working on supporting services capable of giving support for your business application. So for instance, if you run a process and you like to see what is happening inside that process, we have some supporting services that is capable to run on cloud that can give you a glimpse of the process itself and what's going on out there, or even a user task, for instance, in a given process. You can go in this supporting service and see the tasks, and then approve a task or go forward with a process and etc. So there is a lot of features out there in those supporting services as well. And like I said, some cloud tools. We have a specific Kubernetes operator for deploying Kogito applications on OpenShift or on Kubernetes. And I'm going to use the operator in the demonstration. So we bring and pack this all together, and that's what we call the Kogito project. So this is a feature of a handful components to help you design and create your business applications and deploy it on the cloud. Let's go to the use case straightforward. It is, imagine that you have this online store, right? And after new new orders, you create an event in your architecture. So, every new order, we create a new event, and then this event is being consumed by this order approval service. So the service will be some sorts of rules and some sort of business requirements. They say if it's approved or not. So that's the state of the architecture right now. And John Doe, the CEO, come to you and say, hey, before approving the order, I'd like to go through a shipping and fraud verification first. So whatever comes a new order, before approving it, using whatever features that you have now, do a shipping and a fraud verification for me, please. And I like to run that in parallel, because we can then concentrate the approval in the end of this order processing. So, and you came up with, okay, so what about like creating a pre-processing workflow? So when it comes a new order event, we are able to split this process inside like 2 events. You can create 2 events after of this workflow. Within this workflow, we create a shipping handling event and a fraud evaluation event. So each component in the architecture can listen to this event and react upon it and do whatever they want with that. So in our example, we have the international shipping validation service, and we have the domestic shipping validation service. They are listening for the shipping events. And we have the fraud evaluation service that is listening for the fraud evaluation service. Also, we finish with the shipping validation. We meet a new event saying like shipping verified or something like that, and after the fraud evaluation service is finished, like can say, hey, this looks like a fraud, or does not looks like a fraud. It can be anything. And in the end, we have our order approval service again, and you can correlate all those events by, like, for instance, the order ID, and say, hey, I received the shipping approval, I received the evaluation approval, and I received this new order event. So I can correlate the 3 of them, and then I can proceed doing whatever they want. So this is a small excerpt of a small processing use case in our example. So I have like 5 services running around. None of them knows about each other. They just listen about events. So that can be, an event-driven architecture, an event-driven applications. They're just reacting upon events and emitting new events, and it can add new components in your architecture. So you have this flexibility of creating things around your architecture, removing an event, adding another. So for instance, tomorrow you won't ship internationally anymore, and you just remove the international shipping validation service. There's no use anymore, right? You won't have to code something new or anything like that. Just remove an event from your you just remove a service from your architecture, and you stop doing that thing. Or no, well, I wish to add some new capabilities, so I add a new service in order to listen to this event and do whatever I want. So this is more or less what an event-driven architecture the benefits of an event-driven architecture can give to you. Async processing, this kind of flexibility, composition and orchestration of events. That's why we are talking today, like about the workflows, for instance. So let's try to zoom into this first service, the order pre-processing workflow. Let's say how it is doing. Its things. So I draw this workflow like in order to pre-process my order. So I receive this new order event, and I will process the order. I split into 2 parallel states, saying I will handle fraud in one state, and I will handle shipping in another state. So I can figure if which kind of events I need to produce for my architecture. So this is happening inside that pre-processing workflow service. So this is more or less what looks like my workflow. Let's see how this workflow works, and it is described, how I am describing this workflow in a YAML format using the serverless workflow specification. So I broke the workflow into 3 workflows. I have the main workflow, the order workflow, and I have one state here that we call the parallel state, calling those 2 subflows, the fraud handling workflow and the shipping handling workflow. So let's take a look at it. The first part of the workflow, it is the I call the headers. When we describe, we give some information about the workflow. So the name of the workflow, the identification of the workflow, version for you to control the version of the workflow, some description for it, and I will say which state I will start my workflow. In this case, the receive order. The second part, I have the events definition, when I define how I will consume that event. So let's say that in this particular use case, I have the order event type, cloud event type. So someone out there, any service out there is producing this ordered event, cloud event for me, and I'm capable of listening to it. So the first state, the receive order, it is capable of listening to this event, the order event here, that we tie with the name, like order event name. I have the event by his name. It is the order event here. And when I receive this event, I say transition to process order. And this state process order, which I call type parallel, I will create the branch fraud handling and shipping handling. Let's say my engine will call, at the same time in parallel, those 2 subflows. And once they finished, I end my workflow. And to create those workflows, I'm using the serverless workflow plugin, and you can download it in the VS Code marketplace. It is maintained by the serverless workflow community, specification community, and you can go there, see the source code, do whatever you want, download it, and please hate 5 in the plugin itself. And we have this nice feature that is you can generate diagram using any workflow file. So it uses this simplification of the event diagram from UML. So we have a start, we receive the order, it is an event state, we process the order in a parallel state, and we create 2 branches. So let's take a look into the first one, the fraud handling workflow. Same thing, I have the name, which state I will start, the version, and the events that I'm going to produce. So I'm going to produce a type event orders.fraud evaluation. And let's take a look into the states. So we have a data conditioning here, which is when we start this workflow, we analyze the data inside the input of my workflow, and we perform a JSON path expression into this data. And if the total of my order is is greater than 1,000, I would say that we need fraud verification. If it is under 1,000, I won't need fraud verification. Of course, this is super lame an example. In real use case, you won't do things like that. You can create a state before that. Like you can call a service to evaluate some aspects of taxes or behavior of the customer, whatever thing you want, and then you can say to the workflow, hey, this order looks like they need to perform is to be validated the fraud or something like that. So for this case, to simplify the conditions, we have this event type switch, and I have these conditions in here, very lame, but it is super nice. And I inject into my data state a new attribute to my workflow. The fraud evaluation equals true, and then I produce the event fraud evaluation. And this event contains in the data attribute everything that I created here in the workflow. So it goes with the fraud evaluation equals true and the order information as well. So anyone that is interested in the orders.fraud evaluation event can do something with it. All right, so let's do the same thing that we did, and let's generate the diagram using the plugin. And as you see, we see that we have like a fraud handling switch state, and depending on the condition, I'm going to say that we're going to produce a fraud evaluation. If not, otherwise we just end our workflow. Well, very simple, and hopefully you could understand what is happening there. The other workflow is the shipping handling workflow that is being executed at the same time as the other one. More or less the same thing. We have now two types of events. We have international shipping order event, and we have domestic shipping order event. So depending on the context of my order, I will emit we produce an event like an international event, a shipping order event, or a domestic shipping event. And more or less the same thing that we did there. We have also a switch state case here. And the first condition it is like if it is within US, is a domestic shipping. If it is not, it is an international shipping. Again, super lame example. In a real use case, you can like call a shipping, maybe you can call it maybe a Google service for localization to find the address, the correct address, and then to figure some other things out of whatever, and enhance your order data with some output for this service, for instance. But in this case, after if we realize that this is a US order, so we transition to domestic shipping. If it is international outside US, we handle for international shipping. So for domestic shipping, I'm going to add a new attribute to my data that is shipping domestic. Otherwise, I'm adding shipping international to my data, and I will produce an international shipping order, and I will produce a domestic shipping order. Again, super simple, but you can see the powerful of something. So imagine that you're talking with a business person, and you can bring the DSL to them and explain, hey, this is what is happening inside these microservices. This is which kind of events that we are creating, that we are consuming, and what we are doing with it. So for instance, in a real use case, you can say, hey, I'm calling this Google service, and we can receive this kind of information, and we can process this information as we please using the workflow. Let's see how it looks seeing the generated diagram here. So we have this the shipping handling state. It is a switch state, and we go with can be a domestic shipping or can be an international shipping as well. As you see, in the end, we are going to produce an event being international or domestic shipping whatsoever, and we are going to win. Well, that's what looks like the event when you see it in this perspective. And of course, this is when you are designing and we are creating your workflow. When it turns out to deploy and into a Kubernetes or an OpenShift cluster, for instance, or in the cloud, you can use the capabilities of the Kogito. We have a CLI. So in this case, you can deploy the workflow using this command line, like Kogito deploy, that is the action, the verb of what we are doing, order serverless workflow, that is the name of the service that I gave. And you can add all those YAML files into the CLI, and the CLI will push, in this case, to an OpenShift cluster. And in there, we are going to generate code based on those files. and we create an image, a Kogito process runtime image into your internal web registry, and the Kogito operator will be capable to create the Kubernetes resources and the Knative resources to deploy and have this and to manage this workflow, running within the platform itself. And of course, for this use case specifically, for this working with events with Knative, we need the serverless platform. This also works on Kubernetes, but on Kubernetes you can build within the cluster. You have to build the image yourself and then push the image to the cluster, and the Kogito operator will take your image and you perform the same steps. You create the Kubernetes resources, you create the Knative resources for you, and for your service to be connected with the Knative broker in this case. Diane, I see that we have some chat going on there. You'd like me to stop here, or we can answer the questions after the...
Let's answer the questions at the end. And most of the chat is me trying to get people to ask questions. So this is a good point. If people have questions, type them into chat, and we'll make it happen at the end. Thanks.
All right, no problem. Yeah, I don't know if I'm rushing or not, so you tell me. All right. Once we have that service deployed on OpenShift, this is more, sorry about all the technical details, but this is how it looks like from the Kogito operator perspective, how we deploy the service in there. So our service will be like an event source, or this event source can be any other thing. In this case, we have the serverless workflow in here. And we are listening to the new ordered events coming from the Knative broker, and we consuming using Knative eventing triggers, and that triggers an event for us to listen to it. So the ordered event comes here into the broker, and we listen to it, and we start our workflow. Our workflow will produce events to the broker using sync bindings. So we produce events to the Knative broker and any other service out there, any other, can be a Knative service, can be any deployable pod or anything else, in the spectrum of the Knative serving platform, to be listening to this event and to react upon it. And this is what we are going to see in this short demonstration. Let me see. I think this is not in. Let me try to zoom that. Well, can you guys see this?
Yep, looks great.
All right. So I'm producing an event to the platform, and the country is US. The total value is 1001, and is an iPhone 12 order. So I'm going to push this event to the platform, and you see what will happen in there. So in this terminal here, I have 3 listeners of our Knative of our workflow event, producing events. So in the topmost, we have the fraud evaluation service. So we are listening to the events from the fraud evaluation service. We have the the shipping international here in the left, and the domestic shipping here in the right. So once one event comes to either to the fraud evaluation or to the international or domestic shipping services, you will see the produced event in here. So let me push the event. It is like a fire and forget type of event. It's taking some time because my internet connection is not that good. So I push the event, and we can see that we didn't have any pods and listening to that, because those are Knative services. And we receive a fraud evaluation because the value is above $1,000. And we received a domestic shipping because the country that we ship our iPhone, it is within US. It is a order from the US, so that's why it is a domestic shipping, and you can see it in there. And if we go to the OpenShift cluster, You can see, hopefully you can see, if my internet connection helps. Help.
It is a live demo, damn.
Yeah, you already saw those, like, because I'm fetching for the pods of the shipping international service, and you see there is no resources in there. And yeah, I don't know what is happening. I don't know if I need to refresh this, but whatever. And you see that is this event coming in here and this event coming in here. So there is some extensions in as well. So we have some information about the process itself. And here you can see that the fraud evaluation service received the fraud evaluation equals true, and the domestic shipping service received the shipping domestic. And this shipping domestic is not, it is in here, but the fraud evaluation is not in here because we run one after the other. Well, let's see if, yeah, we can see the pods in here, and because we were talking, Knative will destroy the pods because they are not being used. So that's why we are seeing terminating in here. So let's say that we have, I don't know, maybe a new order from Italy, and that's above $1,000 as well, and I'm gonna send it quickly this time because the pod is already there. I'm creating the Ship International pod in order to listen to this event and react upon it. And the same thing, you won't see fraud nor domestic here because we enter in that branch that we just received from the international shipping. So now try to imagine this in a real use case where you have to equalize your resources. You have to save resources in order to have a more profit company. So in this case, let's say that you receive, I don't know, maybe 9% of your orders, they are domestic. So you don't have to have like the international shipping handling services be up there all the time. You can have the workflow to control all the logics, and you can break through into categories. You can break your domain into more specific things, and be flexible enough to distribute your services around your architecture, and you won't have all the you won't waste resources into something that you won't need for some time. So this is a nice example, or a nice use case for you to maybe reevaluate some of those things that we are doing, because normally people create like huge microservices. They're doing lots of things, and maybe sometimes it is nice just to break into specific parts and make them run into this fashion. Like I can create like lots of domestic orders or lots of international orders, and having this part of my system not producing services or producing events, not whatsoever. So I can reduce my cost, and sometimes that will help a lot. Well, let's get back. There's some much more things that I'd like to discuss. There is lots of details and subtleties about it. I know that was super quick and brief things. I introduced lots of concepts, like the cloud events, the serverless workflow specification, the Kogito project, how to deploy it, the Knative. There's lots of things out there. And also lots of resources. You can go there in this on our websites and see what we are doing and the use case that we are capable to help you solve your business problems. So reach out to me as well. I have Twitter account. You can send me a DM message or send an email, or reach out into GitHub or whatever. I'm up there. You can see. And I would like also to to ask you guys to take a look in the blog as well. We are trying to update the blog like twice a week, and with new content, and to give people an understanding of what we are doing in Kogito and the business applications in general, and how you can solve your business problems. And if you're curious about the demonstration, the example itself, you can go into this we're holding here and see all the source code. You see the workflow. I create some scripts in there for you to deploy in your Kubernetes instance. We have the image already in there. No, the Docker file, sorry, already in there. So you can go download the Docker file, run, build the image, run the image locally. You can play around this demonstration wherever you want. And I'd like also to invite you to see this the presentation from last year that Tihomir and I did. Tihomir is much better than me explaining the cloud, the serverless workflow specification. And there we go through more details about the specification. And if you're curious about it, just go in there. And of course, the serverlessworkflow.io website, you have all the links that you need to know there. Our Slack channel, our mailing list, our weekly meeting, and everything else you see in the resources. Okay. Well, thank you. That's it. I don't know if we have any questions or not.
We've got some time for questions, and there's a couple of them in the chat. So and I'm going to try and I'm going to do them in reverse order because I think you answered some of the earlier questions already. And Eric is asking, why was Knative chosen to increase the workload capabilities and not an autoscaler?
Well, just for the demonstration purposes, actually, we can use autoscaler. That's not a restriction whatsoever. I just found that more simpler to to show to users what we can do. And then in the example, you see all the Knative resources for you to replicate the exact same thing in your environment as well. So yeah, not particularly any reason whatsoever.
Okay.
But sorry, but for the Knative eventing part, it is because the Kogito engine, actually we have these connectors, and the Kogito operator as well is coded, and we have this support for the Knative eventing platform. So we created a specific Knative eventing resources for it. So for the Knative eventing part, that's why. But for the Knative serving part, can be whatever thing. The autoscaler, or it can be regular deployments, whatever. That's no particular reason.
Cool. Right, and there's one other question from Ilian. Is it possible to create custom code?
Oh yeah, of course, because this is a Java project. It's a straight through Maven Java project. In the example itself, I have a README file here that I explain how let's see how you can create this a serverless workflow Kogito project from the scratch using Java. So you have to know Java, but yeah, you can add custom code, and you can call this custom code using a workflow. We have a specific in the Kogito implementation. We have specific functions that you can declare in here for like you can give a name, and then you can in the metadata space we have a what we call like a service internal calling. So you can call any Java being from the workflow. So yeah, you can do it. But from the specification point of view, we have the JQ capabilities. So you can like create a function expression, and then externalize this. We can define here the function that is an expression as a function, and you can declare any, if your custom code it is related to data handling with the input, you can just create the expression and in here in the workflow itself, and that will work. I don't know if I answered.
Yes. And he's assuming you can call out to other services during execution. Ilian would like to be able to call out to fraud prevention API that they have. So
yeah, absolutely. Let me show you the specification itself. Yeah, you can call any functions. We have three in the specification. We expect the RESTful service invocation, RFC service invocation, and also expressions, like I said before. In the RESTful, you can define like a function like this. Let's say send order confirmation, and the operation of this function, it is an open API definition file, and after the hashtag here, you have the method the operation ID of that particular open API. So for example, let me see if I can find it.
Oh, the famous pet store.
Yeah. So imagine that you have like this one here, this open API spec here, and you would like to call the list pets function. So you just say, hey, this is my file, and this is my operation ID. So the Kogito engine will read this specification and will generate client code to call this REST service. So yeah, you can call it, a third-party API and do whatever you want within your workflow. So after receiving the payload of the response of the list paths, you can do whatever you want in your workflow. Yeah, that's correct.
Okay, and so someone's now asking, where are correlation keys state stored if used?
Well, the correlation ID, it is we are working on a stateful implementation, so we don't have it yet on Kogito side. But in the specification, we have the part where we define. Let me see if I can find it real quickly. Oh, very on top of the hour. But here. In the events, you declare the correlation in here. So in this use case that I brought, in the end, in the final order process, so if that process would be like a workflow service as well, because I don't know what it is. It is just an example that I gave. But if it is a workflow as well, you can create the correlation in here in the workflow, and say the event, say, hey, the attribute name, it is ordered ID, for instance, and then you can when you receive everything else, you do whatever you want. In Kogito, we don't have stateful yet for the serverless workflow, but we are working on it. But in this case, we are going to handle that in memory. So we receive that at the same time, we correlate, and we do all the stuff. But we are looking forward to implement the stateful.
Cool. All right. Well, there's one earlier question. I think you might have answered it, but someone's asking for an understanding of how this relates or differs to CamelK.
Well, Camel is for, I'd say, integration most of the time, the implementations of integrations, and we do not target integrations. So you cannot like FTP a file or send an email or do things like that. It is not what we are discussing in here. And of course, you can implement a pipeline in CamelK. This is not the idea. But from our perspective, it is more or less a declarative workflow of a feature that we are implementing in here. It is not like dealing with integration side of the things. I understand that is some things that they can interconnect, or we can implement an integration in here. Like for instance, you can call a tweeted API using the REST function, of course, or you can in the CamelK, you can create a route that you go through every step as we created in here, of course. But I understand that each tool has its particular strengths, and you should leverage from that. So from the workflow side, sorry. I'd say that for this kind of declarative workflows, business applications that we have, this is a suitable application for this kind of use cases. That's my point in there.
Okay, cool. All right, and so we are almost to the top of the hour, and the very first question was, where did the name come from?
Well, that's something that people ask sometimes, and then I'm sorry, I I can explain it exactly why the founders they come up with this name. But everything that we do in Kogito, it is like related to knowledge. So we call ourselves the key. So the knowledge is everything. That's our motto. And because all these rules, decisions, process, everything is related to business applications and knowledge based. And it is, I believe, is based on, of course, the founders can explain you much better than I. But from this quote, Cogito ergo sum from René Descartes, you can read the Wikipedia. Right. But yeah, and the K, because Kubernetes, it is a cloud-based platform, so that's why that's called Cogito. I don't know if I answered your question. Hopefully,
I think that's great. You know what the best part is? It's not a Greek or navigation term. So that's really the most wonderful thing. It's like we have completely run out of K words, and
yeah,
we're
true.
stretching it in the Kubernetes cloud native space. So you've done well. So we've got like 4 minutes left. Sure. Is there some new features, or what's in the roadmap? What's coming up next that we should be watching out for?
Well, like I said, Kogito is a work in progress of the serverless workflow specification. So the workflow specification is going super in the community. We are creating great things in there. Great big companies are interested in the specification. This is a very nice thing from the community side. We are about to release 1.0 from in the specification, so this is a nice thing. Hopefully, we'll see more people trying to implementing it. And from Kogito side, we are keen to implement everything that is there in the specification to be 100% compatible with the specification. We are about to bring JQ to the engine, so you can create JQ expressions in your workflow, and so you can transform or do whatever you want with the data within the workflow, and of course state. This is a very important thing that we're looking for, to implement in the engine as well as error handling, compensation, and all of those workflow patterns that we don't have yet from the workflow, from the serverless workflow perspective. But yeah, there's a lot of work to do in there, and from the specification and the implementation side.
Yeah. So if you can share again that resources page, because I think that's a great way to end. And if people want to get involved, then follow the links.
Oh, please.
And,
yeah, in the front page of the specification, if you go here in the specification, you see our GitHub page, and you can see. Oh, I'm sorry. All the information that you need, mainly how to engage with the community. We have a Slack channel under the CNCF Slack, so please go there and say hello. And if you have any other questions, just reach out to us there. We are keen to help, and looking for contributors as well.
Well, thank you for making this really interesting and engaging talk, Ricardo. We'll definitely have you back to celebrate maybe the 1.0 release, and and just keep us in mind. And there were plenty of great questions today, so thank you everybody for tuning in, and Chris Short for producing in the background there. So really pleased to have you here, Ricardo. Definitely come back and keep us posted and up to date. And everybody, join us on the community Slack channel if you have questions that he didn't answer today. We'll try and get them there. All right. Well, thank you, everybody. And again, Ricardo, thank you. I love the hand waving while you're talking. The most expressive virtual event so far.
Yeah, I'm trying hard.
All right. Well, take care. And thanks, everybody.
Thank you, guys. Bye.